In this video, we're gonna find, guess what? Yep, the power once again. Okay, so yeah, basically in this video, we're gonna find the power of a voltage generator. And we're gonna have to specify whether it's actually erogated, so it's basically generated, or whether it's absorbed. I know what you may thinking. You are probably thinking, hold on a second, it's a voltage generator. How can it absorb current? It's an active element, it's not a passive element. Well, kind of. There are some very particular cases in which a generator can actually absorb power. And although we generally refer to it as an active element who is prone to, erogate and generate power, it may absorb power as well in some very, very particular cases. Is this one going to be one of those particular cases? Who knows? But hopefully you want to find out. So let's crack on and get to work. So our circuit this time looks like this. We have a voltage generator, which is like this. Okay, so pointing down. Then we have a resistance. Then we have a current generator pointing in this direction. Then we have a node. And then we have another node. And then down here we have another voltage generator pointing down like so. Then I'm gonna call this ES. Oh no, ES. And then down here I'm gonna have a resistance, and then at the very bottom everything is gonna be connected. So here in between, because it's not over, in between I'm gonna have first a resistance and then another voltage generator. But in this case it's gonna point up, so plus E minus. And down here I'm gonna have first a resistance and then a current generator pointing down. I'm gonna call this I. This one is gonna be my R1. This one is gonna be my R2. This one is gonna be my R3. And this one is gonna be my R4. Now, I'm gonna oh, and this one is gonna be my I. And I'm gonna find the current flowing down here as I of S. What is the problem saying? Well, the problem is saying for the circuit below, we know that E is equal to 10 volts, ES is equal to 10 volts, I is equal to 5 ampere, R1 is equal to 20 ohm, R2 is equal to 5 ohm. R3 is equal to 5 ohm. R4 is equal to 10 ohm. Find the power P of the voltage generator ES, and specify whether I don't have space. It's generated, irrogated, or absorbed. Okay, so we know a few things about the circuit, and we're gonna find the power of this guy here, and we got to specify whether is actually absorbed or whether is generated, is irrogated. So what are we going to do here? Well, I can actually do one thing. I can actually say, right, I can use Thevenin at AB by saying AB. I'm gonna put AB here. Okay, so AB like here between these end and these end, and I can actually find the equivalent circuit of Thevenin for the point A, B, which we're gonna say, okay, are gonna be those two, A and B. Okay. So the Thevenin equivalent circuit and AB. Okay, so if I do just that, I can say, okay, before getting there, I want to find RTH, R of Thevenin. So without taking into account the current, by putting AB here on these two ends, and without taking into account the current generator and the voltage generator, I will basically have an open circuit here instead of having current generators of two current generators, and I'm gonna have a short circuit here instead of having two voltage generators. So I will basically have this, and then still my resistance here, and then on here I will basically have a short circuit, and on this side I'm still going to have these resistance, but then down here I'm gonna have a short circuit, as I said. So a short circuit, and here again this is resistance, and I'm gonna have, well, an open circuit this time again because it's a current generator. So an open circuit, and then here I'm gonna, as I said, I'm gonna have my two ends A and B. Now if I wanna find RTH, so the R Thevenin is actually going to be given by R2 plus R3. So oh well, I didn't my fault. R1, this is R2. Ooh, I'm an idiot. I am an idiot. And this one is R3, and this one is R4. So RTH, as I said, is going to be R2 plus R3. So R2 plus R3. So RTH is, and I didn't even put the value of those resistances, but anyway, R2 was 5 ohm and R3 was 5 ohm, so 5 plus 5. So RTH is going to be 10 ohm. Now, in order to find VTH, I'm going to consider the mesh CDAB. I'm going to consider the mesh CDAB. Okay. Which is basically my generator, my resistance, then my current generator I, and then here my resistance again, and my voltage source here with the plus minus E, and here again resistance and a current source, and then on this end I'm gonna have A, and on this other end I'm gonna have B. So plus minus VTH. This is gonna be my VTH. Whoops. This R1, R2, R4. I mean, why do I keep forgetting this one? R3. Yeah, it's important, R3. Yeah, I'm sorry, R3. I don't know why. Anyway, so I'm gonna find the current flowing here as I. Yeah. So now I can just apply Kirchhoff current law to the node C, and you may be wondering, okay, but you didn't tell us, you didn't at least tell us which one is the node C. The node C is this one. I mean this one. Sorry for not specifying. So as always, this is a node. I'm gonna apply Kirchhoff current law to node C. So Kirchhoff current law, the sum of all the currents entering a node is equal to the sum of all the currents leaving that node. So which one are the one getting into and which one are the one going out? Well, and by the way, this is we have a current here as well. So, well, we can say that I is getting into that node. So let's just say, yeah, we have I on one side, which is the only one getting into that node actually. And So I is gonna be, we would basically have well, in this node it's actually, well, it's actually, no, it's actually zero. It's actually zero because we would have negative I plus I2 plus I equal to 0. So we would have that I2 would be I minus I. So those two cancel. So we would have that I2 will be equal to 0. So in R2, there is no current. In R2, there is no current actually. This will be I2. So I2 will be actually 0. So we will have two currents in the opposite direction, then this one leaving the node. So this one leaving the node will be left alone, and we'll have I2 equal to 0. So in R2, there is no current. Now I can apply Kirchhoff voltage law to the, well, to the nodes, only to the mesh, to the mesh C, D, D, B. So what do I get? Well, I get E minus VTH minus R3 times I equal to 0. So I will actually get negative minus VTH equal to negative E plus R3 times I. So VTH is E minus R3 times I. So VTH, if we plug numbers into this, we have E, which is 10 volt, minus R3, which was 5 ohm, times I, which was 5 amps. So VTH will actually be, well, we'll have 10 minus 5 times 5, so basically 10 minus 25. So basically VTH will be negative 15 volts. So we have found our VTH, which is fine. Now, what I gotta find is IS. So basically going all the way back here, I'm gonna find IS, the current flowing here, because once I've done that, I'm gonna be good. Like, honestly, I'm gonna be good. So to find IS, let me just redraw this, because all we have done was to make the Thevenin equivalent circuit. So Thevenin equivalent circuit is given by VTH is resistance, so a voltage generator in series with resistance, just like Thevenin says. Then this one is still gonna be my node A, all the way down here where I find my node B, and here I'm gonna have my generator E of S minus plus, and the current here I called it IS, so it's still going to be IS, pointing down here, I of S. So as I said, I can actually apply Kirchhoff voltage law. So Kirchhoff voltage law. And if I do that, what do I get? Well, I actually get that ES plus VTH minus RTH times IS is equal to 0. It's a kind of nice mesh to work with, isn't it? The 7-in-1. So if I plug numbers back into this, I get ES, which is the voltage generator by ES. Oh yeah, 10 volt. So it's 10 plus, but it was negative, so it will be negative 15. Minus RTH, we found it was 10 ohm, times I of S, which is the one we're trying to find, so times basically I of S equal to 0. So we have done negative 5 minus 10 IS is actually equal to 0. So we have that negative 10 I of S is equal to 5. So I of S is actually equal to negative 5 over 10, which I can simplify as 1/2. So I of S is equal to negative 1/2, which I don't like. So I'm gonna write it as negative 0.5 amps. Now we are almost over, because the problem was actually asking us to find the power P of the voltage generator. So we know that the power is basically the voltage times the current. So the power is E of S times I of S, the voltage times the current. So P is actually equal to, well, E of S was 10 volt times I of S, which we have just found is negative 0.5 amps, so negative 0.5. Therefore, P is equal to negative 5 watts. And since it's negative, the power is absorbed. Since it's negative, the power is absorbed. There we go. So yeah, as you can see, voltage generators in this case are absorbing power. It's one of those very, very particular cases in which a generator is not generating power, but is absorbing power. So yeah, as you can see, it's not like just like that. It's not straightforward that when you see a voltage generator, you say, oh, okay, yeah, that's a generator, is definitely gonna generate power. No. It may absorb power in some particular cases like this one. So yeah, that's it for this example as well. I hope it helps, and let's crack on and get on to the next problem, but in the next video. Cheers and bye for now.